this is a crossroads. We are looking from the top. There is a body of mass 2 kg which is coming this side with 5 meter per second. And over here also, from here, a body is coming with 5 meter per second, its mass is also 2 kg. So more or less you see that is both the cases, they are more or less identical. It's only there is a direction difference. They collide over here and then certainly they shall be moving in this direction. The values they have been deliberately taken to be same, so that even by common sense we can say that is if these two blocks they collide over here, they will be moving in this direction and this angle will be 45 degree. Through common sense also we can say it. Whatsoever is the momentum of this, the same momentum of this, whatsoever the power, more or less. So crudely we can say whatsoever is the power of this, same is power of this. In general terms, it is not power, that is what we are talking about in work power energy. So this comes over here, this comes over here. So there is no reason, that is it gets a preference towards one of the axes. So it will be moving in this direction at an angle of 45 degree. So it is easy to understand this angle will be 45 degree. Now let's use conservation of momentum principle and see that this angle comes out to be 45 degree. So over here what we see is that these two bodies, they collide over here and then they move in this direction with the velocity v, making total mass 2 and 2, that is 4 kg with the velocity v. In this direction they move as a one body. So there is no external force on to the system of these two bodies, so their momentum is conserved. Their momentum is conserved along x-axis also, their momentum is conserved along y-axis also. So in this case, their momentum is conserved along the x-axis also and their momentum is conserved along the y-axis also. So let's first understand in the simpler terms and let's conserve momentum along both the axes. Momentum along the x-axis is equal to conserved. So it means we can say momentum before collision is equal to momentum after collision, that is along the x-axis. We are talking about the x-axis now. Momentum is conserved along the x-axis. So what does it mean? That is momentum of this mass into velocity plus 2 into what velocity? Velocity along the x-axis. We are talking now about the x-axis only. So mass into velocity along the x-axis plus mass into velocity along the x-axis. It is purely moving along the y-axis. So its velocity along the x-axis is 0. So it is going to be 2 into 0 because we are now considering momentum only purely along the x-axis. Through common sense, we understand this angle should come out to be 45 degree. Let's see that. So mass into velocity plus mass into velocity along the x-axis is equal to mass is 4. If this velocity is v over here, so this is going to be v cos theta and this component is going to be v sin theta. We know very well that is how to break the vector into its rectangular components. So along the x-axis momentum is going to be 4 into v cos theta. And if we say along the y-axis also when the momentum is conserved, that is along the y-axis momentum is conserved. So we can say it's the same thing, the momentum before collision is equal to momentum after collision along the y-axis. So that means that is momentum before collision. This is 2 into, now we are considering along the y-axis. Its velocity is purely along the x-axis. So 2 into 0 plus 2 into 5, 2 into 5 in the positive y-axis. This is going up. We have taken this as positive. Is equal to total mass 4 into, this way velocity is what? Mass into velocity. Velocity is what? V sin theta. This we take, suppose we take this is equation number 2 and with this take as 1. If we divide equation number 2 by equation number 1, so this comes out to be, this will be on top, this will be on the bottom. So we know that this will come out to be 4v sin theta. If you look over here, 4v sin theta, this will come over here 4v cos theta, and this way it will 2 into 0 is 0, 2 into 5 is 10, and if you look over here 2 into 5 we are doing 2 by 1. So this we have written over here 2 into 5 10. So this comes out to be 4v get cancelled. So sin theta by cos theta tan theta. So tan theta comes out to be equal to 1. So theta is equal to, tan inverse 1 or theta is equal to 45 degree. Obviously that is through common sense also we knew that is the answer should be 45 degree only. We can put the value over here in any of the equations and we can get the value of v also we can get. If we intend to do it purely on the vectors, using vectors, what we can do is directly we can apply, we don't have to break it into components. So we say that is momentum before collision is equal to momentum after collision. Let's say momentum before collision. So it is mass into 5I cap plus momentum of this 2 into 5J cap. Now you don't have to break into components. Vectors will take care of themselves. Is equal to, finally momentum is 4 into V vector. We don't know what is the direction or what is the angle, what is the magnitude, we don't know, but we can calculate from here. So this comes out to be 10I plus 10J, so 4V. This comes over here, so 10 by 4, that is comes out to be 5 by 2 I plus 5 by 2 J is equal to velocity. So it means what? 5 by 2 I, it means the velocity component, one is this way, the other is this way. So angle is, obviously theta is going to be 45 degree, as we can easily see if we have an elementary understanding of vectors. Magnitude of velocity comes out to be under root of 5 by 2 square plus 5 by 2 square, and the magnitude comes out to be of velocity vector magnitude comes out to be under root of this square plus under root of this square and meter per second, and we can get the answer.